So today we solve a class 12 CBSE board specimen paper of physics 2025 and 26 session, and that specimen paper released by CBSE.org website. Okay, their own website. So that's is very important for the specimen paper because that's almost follow the similar pattern in board exam. So that's why we solve these 33 question here. We solve the all question are composite. Solve this. There's a general instruction. So today's lecture actually solve that maximum number of questions. But today solve this part, and next part will solve the rest number of numericals. Okay, our question. So here there's a 33 question. All question are compulsory. There's a this paper have 5 sections: section A, B, C, and D, and section E also. All sections are compulsory. The section A contains the 16 question, 12 of the MCQ, 4 assertion and reason based of the 1 marks each, mainly the MCQ based, and there is some case study. Section B, okay, that's very important, and there is no overall choice. Okay, so here is some constant, that's very important. Do not remember the constant. There's a constant is given here on question paper, so that's why that is very important to see that the constant here and put. Now start the solving the question. There is section A, question number 1. So question number 1 given here: if a charge of hollow sphere and a solid sphere of aluminum and copper, okay, there is a two sphere, one sphere is made is aluminum, other is a copper, have equal radius and in electrostatic equilibrium, then which of the following statement is true? Okay, so we know that the formula is V equal to C upon Q. Okay, and that C capacitance, that is directly proportional to, or say that equal to 4 pi epsilon naught times R. So that is mainly C is directly proportional to radius. If both radius be the equal, if the equal radius, okay, so means they have equal charges. So both have sphere have equal charges. That's answer the correct. The hollow sphere will have more charges than solid sphere. There's no hollow sphere here actually. That's not signified here. The aluminum sphere will have more charges on its surface than copper sphere. So if hollow sphere is also made up of aluminum, then it will have more charges. Mainly the one is the correct answer. Okay. Now question number 2. If coil n number of turn, okay, there is insulated in copper wire of diameter d and resistivity rho, owned a cylinder of diameter d, what is the total resistance between the two end of coil or of copper wire? If the given is capital D is much greater than smaller d. So see that a copper wire diameter is small d and that cylinder diameter is capital D. Okay, so here we need a total length. So total length find very important. That is equal to number of turns n. Okay, and there's a diameter and the circumference is diameter, radius is d by 2. So 2 pi d circumference. So 2 pi d, that is d, sorry, not only 2 pi d by 2 radius, 2 pi d by 2, that's the diameter, diameter by 2 get radius, 2 cancel, that is n pi d. There's a length. Okay, first find the length and actually put here R. We know the formula, R equal to rho L by A. Okay, now rho is resistivity and the L is given n pi d, the number of turns pi, and is the diameter by A, area, means obviously cross section area, pi, radius, so diameter by 2. Okay, so that is very important. That is the copper wire. Okay, sorry, that's the copper wire, so that is d by 2 whole square. So finally we get pi n pi d times here square with a 4 by pi small d square. 4 rho n pi with a cancel, 4 rho n d, 4 rho n d by d square. Okay, that's the answer. That is 4. Put 4 here, that is 8 to 12. That is obviously the answer 4 is the correct. Now question number 3. A phasor diagram device connected to a AC supply in figure, which of the following statement is true? If V in that I in the air, to see that the AC, okay, so the increase is impedance and there is a decrease. Okay, when the frequency of AC source is increased, frequency is increased, so impedance is decreased. So impedance, say that is suppose it's called X is the impedance is decreased. So they are inversely proportional. Okay, so current leads the voltage. Okay, here. So the given appliance is a capacitor. Okay, so the current leads the voltage. So appliance is a capacitor. So when the AC source is increased, so the impedance of the device is decreased. Okay, that's the answer we get. Okay, when the device behaves the conducting when the connected DC source are not signify here. When the frequency of AC source is decreased with the impedance of the device increase. D is this device storage the energy for magnetic potential not signify that the statement is true. तो ये statement true होगा कि नहीं इससे कुछ पता नहीं चला. So that's why option A be the correct. में ये signify कर रहा है. ये mainly signify है. So number 4. Okay, which of the following statement is true of the radio wave and gamma rays? That's a direct question. Okay, so energy of the gamma rays is lesser than the radio waves. Okay, and the frequency of the radio wave is higher than the higher than that of gamma rays. If radio waves of the radio waves and gamma rays have the same energy, the energy of radio waves is lesser than that of gamma rays. Okay, if the frequency of radio waves is lesser than the gamma rays. So energy of radio waves. So obviously the energy of radio waves, obviously that is lesser than energy of radio wave and gamma rays. Okay. So these energy of radio waves is lesser than the gamma rays. So option D be the correct. Now question number 5. If glass prism of internal angle is 45 degree, 45 degree and 90 degree, the glass has a critical angle of 45 degree. Which are the following ray diagram depict the possible path of the light through a prism? Okay, so you see that that's the 90 degree means that 45, 45. Okay, so critical angle we say the 45 degree. So means that's a total internal reflection. Okay, so total internal reflection here, see, and okay, if that angle is 45, this angle is obviously more than 45. This angle, if is more than 45, as the I, if critical as the total internal reflection actually, and the mainly consideration is that if that I total internal reflection, if there is some angle here, that's okay, that's angle with a critical angle C, or theta C, you say that here, theta C, the critical angle, and you see that says almost there is a critical angle here. So actually look like this. So inside here, because this angle is look like 90 degree 45, so this angle will also look 45. So that's why these be almost A be the correct in these two A and B. And number C, okay, that's not possible. Number D almost is not possible. Okay, because that's due to this. Okay, okay. So option A be the correct. Yeah, due to total internal reflection. Okay. Now question number 6. When light from a monochromatic source is incident on a single slit and the resulting diffraction pattern is viewed on the screen, the graph shows the variation of the intensity with the distance on the screen. Okay. if a slit width increase, okay, if slit width is increased, okay, and so the amplitude also increase, so that the amplitude also increase, so they are the directly proportional, so the amplitude also increases, okay, so that's why if slit is increased, so here there is a diagram here, width of the slit is increased if the intensity of the slope is same, which of the following graph is correct, okay, so no, it's not correct, okay. Yes, because both be the same here, here be the same, here almost these two are almost look like gap be the same, but here is true. Option number D here, okay. If there is slit increases, amplitude increases, so intensity also increases, okay. So that's why D be the correct. So intensity also increases, intensity also increases. Here the intensity be the same, here also be the same. Here it's not signified here actually, because there look like these two are almost a parallels. So that's why these, let's see that its amplitude increases, so that is slit width also, that intensity also increases here. Now question number 7. Question number 7. Which of the following transition correspond to the emission of the radiation of the maximum wavelength? Okay, so here we see that 3, 5 and 7, 3, 5 and 7, 1, 2 and 4, 3, 5 and 7, 3, 5 and 7, okay, these 3, 5 and 7 represent the absorption of energy. Energy. So here 2, 4 and 1 represent that radiation of energy. So here the minimum, so maximum wavelength give the minimum energy. So max wavelength gives minimum energy. So that's why here 1 delta E1, okay, delta E1 obviously greater than here delta E2 and greater than obviously delta E4. Okay, so you see that E delta E4 gives that minimum energy. So represent delta E4 gives that maximum energy, minimum energy, maximum wavelength. So that's give that max wavelength. So wavelength of 1, okay, is less than of wavelength of 2 is less than wavelength of 4. So wavelength of 4 gives the max energy. So that's the correct answer. Okay, that's the question number 7. Now question number 8, a charged particle is projected along with the axis of the current carrying lobe. Which of the following statement is true? Okay, the charged particle moves in a constant velocity. So charged particle actually in projected along the axis, so there is a constant velocity. So the acceleration of charged particle will depend on the velocity. Which of the following is projected? Acceleration of charged particle will depend on the magnitude of the current passing through the coil. Acceleration of the charged particle depends on the radius of the coil, and charged particle will move at a constant velocity. So option D is the correct. This is the correct answer. Yeah. Okay. Now, question number 9. Two small identical magnets are allowed to fall freely through a vertical solenoid of 20 meter made up of copper, and another in the air through the same vertical distance. The time taken of two magnets to fall will be, okay, same in both cases. More for the magnet falling in the air, more for the magnet falling through the solenoid, and D is the infinite. Okay, if EMF induced in solenoid due to the motion of a magnet, okay, remember that if induced mainly depend on the motion of the magnet. So induced EMF will oppose the motion of the magnet. Okay, so here, so EMF always motion of the magnet. So here, this more the same, no, More magnet falling in the air, no. If more magnet falling through the solenoid, that's the correct answer. Option C. Okay. Now question number 10. An EMF generated by an AC generator is given V equal to V0 sine omega t, where omega is the angular frequency of armature of generator. What will be the EMF if the angular frequency is double? That's a very important question. What is if the angular frequency is double? So we see that if angular frequency is double, so V equal to V0 sine 2 omega, no. So that's not double here obviously, so that's these two are the correct. So that's be the correct answer. Okay. Because V we get a NAB omega sine omega t, because that is V that is equal to obviously NAB omega sine omega t. That's the mainly formula. Okay. So option C be the correct answer. Now question number 11. The ratio of the nuclear distance of two nuclei having the mass number 8 and 27 as. Okay. So nuclear density. Obviously nuclear density does not depend on mass. Does not depend on mass. So obviously it doesn't depend on mass. These are not correct, not correct, not correct. That's the correct option. Okay. Now question number 12. When we move a magnet compass from P to Q, which of the following statement is true? If P to Q, okay, question say that is this compass needle move P to Q, not Q to P. There's a current direction, okay. There is the bottom. Okay, and you see that. So option A, deflection of the magnetic needle and P and Q will be the same direction. Obviously not. They will not be the same direction. Okay. Deflection. Deflection magnetic needle P to Q will oppose the deflection. That's the correct. Because there's the deflecting torque in Q to P is a deflecting torque. Actually study that in galvanometer concept. Okay. A deflecting torque, and these are the restoring torque. Restoring torque is the opposite of deflecting torque. So that's why that's the important point. Okay, that's why in the magnetic needle from at P and Q will be opposite direction. Now there is an assertion and reasoning question. The question number 13 to 16, both assertion and reason are true. Reason is the correct explanation of assertion. Both assertion and reason are the true, but reason is not correct explanation of assertion. Assertion is true, but reason is false. Both assertion and reasons are false. The question number 13, total energy of an electron in a hydrogen atom is negative. The centripetal force is provided by a electrostatic force. Okay, that's the important point here. And you see that uh, both actually be the assertion and reason. These two are both true, but there is no relation between A and R. Okay, so both be the true. There is no relation, means option A is not here. Option B, no. Option B, right, sorry, option B, because the reason is a correct, not correct explanation of assertion. So that's why these two are not relation here. So that's the option B here. C true, no. C and D not possible here. That's the option B. Okay. Now question number 14. Assertion: the critical angle of a light passing from a glass to air is a minimum for the violet color. Assertion: the wavelength of blue light is a greater than the light of the other color. Okay. So that is not relation between similar case. Not reason is correct explanation from A. Okay, but that's the true, A be the true, but actually the reason is not true. That's a false reason. Okay, that's the option C. And question number 15, two light sources emitting the wave of the similar wavelength are coherent. Two light sources emitting the wave having zero and constant phase difference are known as coherent source. Hmm, there is two false statements, so that's option D. Not right statement, these two are. So question number 16. If 3 point charges are in equilibrium, that's very important, they are in equilibrium, they must be collinear. And one of the three charges must have different polarity rest of the two. Both assertion reason were true, but reason is not correct explanation of assertion. Okay. Okay. There's the option B here. Now we jump to section B. The magnitude of the magnetic field of a plane electromagnetic wave of propagating along the x-axis in a vacuum, that is given 510 in T K cap, okay, that is total that angular frequency given here, rad per second, write the expression for the electric field E. We solve the question number 17. So question number 17 we solve. So given here, take another white page here, question number 17 solve. So B0 is given here, so B0, that is 510 in T. Okay, so obviously T is a Tesla, so N stands for nano, so that is 10 to the power minus 9 Tesla, and omega given, that is 60 into 10 to the power 6 rad per second here, and there is given the E0, that is E0, you know that is velocity selector C, the speed of light B0, and C is a 3 into 10 to the power 8 meter per second. The B0 is given 5, 10 into 10 to the power minus 9. So get a electric field na, so that is Newton per coulomb. So 10. So these 0 cancels, 153 Newton per coulomb. Okay, so K here may the constant, that is omega by C actually. So here why solving this, because the formula is E equal to E naught sine omega t minus kz. Okay, we derive these omega t, okay, time, not time here, actually time here, t, k, wave vector and z direction. Okay, and now we put k, so we find the omega given here, so also E also given 153 newtons. Okay, so okay, and these E depending very important. Okay, and there's a k omega by c, so omega equal to 60 into 10 to the power 6, that is E naught for this. Okay, 10 to the power 6 by 3 into 10 to the power 8, so we get 20 into 10 to the power minus 2 rad per meter. Now put the all here k E naught omega in the equation here, so we get E naught, that is a 153 sine omega, so omega given here 60 in, into 10 to the power 6 times t minus k given 20 into 10 to the power minus 2, 20 into 10 to the power minus 2. Okay, now important, what is the direction here? Okay, that's obviously the given of so that's the k cap direction. Okay, that's the k cap direction here. So if you see the diagram, electric field diagram here, so diagram, okay, let's look like this, and other, okay, so if that magnetic field in k direction, suppose say that is magnetic field in, that's the magnetic field k, so obviously the electric field in that direction. Okay, so that's when that is that x direction. That's the final answer. Clear? That's the question number 17. Electrical Newton per Coulomb. Now, next question number 17. Question number 18. Following the graph of the potential difference across the terminal of a cell against its load current. So now that load current, okay, terminal cell and the load current. Okay. So given diagram, find the EMF of the cell and internal resistance of the cell. Okay. So here given following the potential difference is load current. See that is a load current here at that point. Here is the load current with the 0. Here that point, if load current with the 0, here with the load current with the 0, so that time the potential difference is 6. Okay, so that's when the EMF is 6 volt. When load current with the 0, so difference between EMF and become cell. So the EMF of a cell and, okay, that is the first answer. Now, and what is the internal resistance of the cell? So internal resistance, given the slope, this slope represent the internal resistance. So the internal resistance that is equal to, so here resistance here equal to V by I. So V means 0 to 6. Okay, so 0 to 6, and here is that current obviously. Okay, so current means 12 to 0, 12 to 0. So get minus 1 by 2 means 0.5. If a resistance is not polarity here, okay, so that's means 0.5. So the internal resistance is 0.5 ohms. Now question number 19. A charge cube placed inside a sphere of radius A filled with water and another charge Q2 placed inside a cube of side 2A, which is a vacuum inside. Find the ratio of the flux linked with the sphere and linked with the cube, and parameter of water is given as 80. Okay, so that's a direct question here. We can help solve with the help of the Gauss's law. The question number 19, we help solve the Gauss's law. So from phi, that is equal to Q over epsilon R times epsilon naught. Epsilon R is the relative permittivity. Relative permittivity, and that is obviously known as permittivity of free space. Okay, permittivity of free space. Okay, for in case of sphere, so that is Q over epsilon naught for water and epsilon 0 for free space. That's the equation number 1. And for cube, that is phi of cube, that is equal to twice q, 2q by epsilon naught. That's the equation number 2 here. And there's a ratio is that sphere by cube, that is equal to get q over epsilon w epsilon naught by twice q by epsilon naught. So these two will cancel. Epsilon will be the cancel here, and obviously q will be the cancel. So final answer we get 2 epsilon w. Okay, so permittivity of water is given. Okay, so permittivity of water here is permittivity of water is given. So permittivity of water is 80. What is 80? So 1 by 2 times 80, we get 160. Okay, that's the answer. The ratio means there is no unit here. That will be the answer here. Okay. Next question number 20. 20 part 1. Write the expression of the magnetic force on per unit length between the two parallel thin current carrying wire. Hence, define 1 ampere. Okay, that's a very easy question. So force that is equal to know that mu 0 to current I1 I2 length by 2 pi gap between these two. Suppose these two is called D, gap between these two where, and force per unit length means that remove from L here and we put L here. Mu 0 I1 I2 2 pi D represent there's a gap between two where, that is the I1, that's called I2, gap between these two where be the D. So define 1 ampere, very easy question. So here's the define. If 1 coulomb charge flow to a 1 second in a conductor is given, that is 1 ampere, because I equal to know that Q by T. So Q is the coulomb, is the 1 ampere, Q SI of charge is the coulomb. So the 1 coulomb charge flow through a conductor. So write that here. So 1 ampere defined if 1 coulomb charge flowing through a conductor in 1 second, we get 1 ampere current. We get 1 ampere current passing through the conductor. Okay. Now we jump to the question 20 part 2. Draw the diagram represent behavior of the magnetic field line, diamagnetic, paramagnetic substances. That's a direct question. Okay. So in case of diamagnetic substance, suppose that's a diamagnetic substance and this line is look like, okay, magnetic field. Actually magnetic field do not passing through the piercing through the diamagnetic substance. They almost try to avoid the diamagnetic substance. That अगर इसके ठीक ऊपर से और इसको ठीक अंदर से पियर्स करके नहीं जाएगा, थोड़ा सा ऊपर से थोड़ा सा नीचे से कोशिश करेगा कि इसे बाहर से चले जाए. Try to be the outside of the diamagnetic substance. Try to move the magnetic field outside of the diamagnetic substance. But in case of paramagnetic substance, the magnetic field line try to inside of the paramagnetic substance. Okay, so inside of the paramagnetic substance. Okay, so we solve the question number 20 almost, question 1 to question 120. So next part 2 in the lecture of solve the rest of the numerical. Okay, next of the question, next part of the question, rest of the question. So next class we solve the rest of the question in given that paper. So if you have any doubt, always ask in comment section. I'll try to give the answer. Okay, so we meet in next part. Thank you.